Good afternoon, grade 9s. In this lesson, we're going to be starting our polynomial unit. And we're going to be starting with the beginning with stuff that we've done in grade 7 and 8 when we used tiles to model integers. And then we're going to move on and use tiles to model polynomials. So let's take a look back at what we did in grade 7 and 8. Here's a quick review. So we were using tiles, and those were the integer tiles. So this was an open box, and we used that to represent +1. And we had a shaded in box, which represented -1. All right, so taking a look at that, this was a good question we can start with. I want you to model or solve this question, +2 plus +1, but I want you to use tiles to do it. The first thing you have to do is model +2. Well, since there's two +1s to make +2, we have to show two +1s. It's pretty simple. 1, 2, that's what you get, and the result is 2. Now, to add +1, that's a positive tile, so here we are at +1. Now, when you add tiles which have the same signs, positive and positive, you just simply put them together and you'll have 1, 2, 3, and that's +3. Nothing new here. We've done a lot of this. In fact, it's probably the same thing you did in grade 2 or 3. Now let's talk a little bit more about how the positive and negatives interact. And to do that, we have to do a review of the thing called the zero principle. Now, the zero principle states that if you have two things which are opposite, you take a look here, that's a negative and that's a positive, when you put them together, you get 0. Right? They cancel each other out. So let's take a look at doing this question. -2, well, there's -1 and -1. That gives us a total of -2. +3 is 1, 2, and 3. When you put them all together, though, we have another thing we have to do here, and that's called canceling out. We have to take a negative and a positive, and they form 0 and go away. This negative and positive, that's the same thing, goes away. Now, if you want to put 2 and circle them that way, you can do that for sure. You can just take and say, well, you know, I could do all of them together. These all just cancel out, and that's perfectly acceptable. Now, the last step is what's left over? Well, since this is all 0, you're left with a +1. So -2 plus +3 is +1. Now, when we started this earlier in grade 7 and 8, we just did tiles. And then quickly on in grade 7, we graduated to just doing it symbolically. All right. Now, there's 3 positives here. There's 2 negatives here. So 2 of these positives are going to cancel out. So 3 take away 2 leaves you with 1. Now, whenever the signs are different and you're adding, all you do is subtract the 2 numbers and largest take away smallest, and you apply the sign of the integer that has the most tiles in it. So because this is 3 tiles, that's 2 tiles, your answer's always got to be a positive. Okay, so then we went into solving equations. So first thing we need to do in solving equations is we had to model it. So on the left-hand side, I've got 2 x's, and we know that this was a positive x. If it was shaded in, it would be a negative x. There's 2 of these, plus 3, 1, 2, 3. And this little line right here, that equates to our equal sign. And on the right-hand side, we have 9 tiles. So our first thing we needed to do was to put together tiles which would get rid of these ones here, the added and subtracted first. Okay, so we have to get rid of those first, and then we'll deal with how to separate the x's. To get rid of a +3, all we need to do is put a -3 with it. All right, so if I add a negative and a negative and a negative under here, those positives and these 3 negatives, they're going to cancel. So they're going to go away. But if I do it on the left-hand side over here, I must do the exact same thing on the right-hand side. So what I've done is I've drawn out 3 tiles and put them with the 3 negatives, and this becomes 0. That becomes 0. And of course, to show this on your test, all you do is circle the ones you want to cancel and arrow them out of the way. Okay? Now, once that's done, we'll have this left. Now, you can save a drawing if you were just to take and draw them simplified into groups already. But what we want to do is we want to take each x and put it with an equal number of tiles over here. So an x is equal to whatever these grouped evenly are. And if you take a look, we can group them up. You see that there's 3 with each one of these x's. So our answer, x, has to be a 3. Again, this is review. Right, now for grade 9. Before we can do polynomials, we have to do a little bit of basic terminology and stuff and find out just what polynomials are. So for example, what is a polynomial? Well, here's your definition of a polynomial. A polynomial is a term or sum or differences of terms whose variables have whole number exponents. Okay, so they are whole numbers, integers by themselves, or anything that has a variable which has a positive exponent. Okay. Now, some of the restrictions on polynomials is, first off, you can't have square-rooted variables. You'll learn later that if you have a square root of a number, its variable is actually a fraction, and that's not a whole number. Or variables in the denominator. You can't have that in the denominator. We'll explain later when we do our powers and roots. When you bring a number from the denominator up into the positive or into the numerator, it changes sign. So that would be an x down here would go up and become negative x. And of course, the rule is you can have whole numbers, not integers. Okay, so it has to be a denominator in a positive exponent of the fraction. If the denominator is positive, you can't have that. So here's some examples. 3x squared minus 2x plus 4. You notice all of the exponents are positive. Even this 4 has a positive. Okay, when you have a number with nothing, its positive is, when you have a number with no exponent, its positive is 1. Right? So you'll notice this x, it also has a, as I said, positive 1. Its exponent is 1. This here has an exponent, and it is also 1. So you'll see a 2, a 1, and a 1. Since they're all positive, that makes this a polynomial. Now again, over here, x minus 2. All right, that's a x to the power of 1. This is 2 to the power of 1. So positive exponents. That means this here is a polynomial. Down here, this is a single term 1. This is 4 to the 1 times a to the 1. Both positive makes it a polynomial. Here, 2 to the 1, g to the 1, 4 to the 1. All positive, that's the polynomial. 4 to the 1, h to the 2, minus 5 to the 1, h to the 1, minus 3 to the 1. Those are all positive. That makes this a polynomial. Now let's take a look at the other side and say, what is not a polynomial? Well, one of the rules up here we saw was you cannot have a square root. Right here, it says you can't have square rooted variables. And right off the bat, you'll see the x here has a square root. That means this is not a polynomial. Going down to the next one. Okay, and this time we have a positive exponent, but it's in the denominator. Right? You can't have fractions in you can't have exponents in your denominator that have a positive exponent, because when I move them up here, that's going to become 4x to the negative 2 when you move this up here, and that's your power laws. Okay, this one here is okay, and this is okay, and this is okay because they all have powers of 1, but this part right here, that wrecks it. Next one, right off the bat, you can see we have a negative 2. That means that's not going to work. So each one of these examples violates the rule. All right. This one here has an exponent which is square rooted. This one here has the exponent. That's the exponent which is square rooted. The variable is square rooted. Here we see the variable is got a power which is positive in the denominator, which is not allowed. And of course, negative 2 to the negative 2. That's a positive. So that's a negative exponent, which is not allowed. So those are the rules. So now let's take a look at the parts of a polynomial. This polynomial you see right here has 1, 2, 3 terms. Right? A term is a simple group of variables or numbers which are multiplied or divided, right? But they're never added or subtracted. So this is a term. 3x is a term. 5 is a term. So your definition, terms are numbers, variables, or the product of numbers or the quotient of numbers of these numbers and variables. Okay, so terms, you count them right here. This is considered to be a term, that's a term, and that's a term. Now remember, you include the sign in your term that is before it. Okay, so this term is actually a positive 5 because it's adding 5. Okay, coefficients. The coefficient is the number that's in front of your variable, and it tells you how many of them you have. You have 2 x squareds here and 3 x's. So polynomial here has 2 coefficients. That would be the 2 and the 3. They're both positive because there's no subtracting here. So coefficients are defined as the number that tells you how many variables you have. The term 2x squared has a coefficient of 2, which means that there are 2 x's. Try the next one on your own. All right, so the 3 means you have a coefficient of 3, and it means you have 3 x's. Okay, going on to the next part. When a number doesn't have a variable with it, like this one here, the 5, this is what we call a constant. This number will change. It varies depending on what x squared is. This will change because it varies depending on what x is. But the 5 will always be there. There's nothing you can do about it. It's always going to be 5. So that means it continually, constantly is 5. So this polynomial has one constant, that's 5. And constants are numbers which are not with a variable. They are alone in a polynomial. And a constant is what we call an exact term or still term. Degree. In order to determine the degree of a polynomial, you have to look at its exponents. The term which has the greatest exponent determines the degree of the polynomial. Taking a look here, you get 2x squared, 3x, and 5 with nothing. Now, we can rewrite that as 2 to the x to the 2 plus 3x to the 1 plus 5 times x to the 0. Now remember, 5 to the 0, sorry, x to the 0 is a 1, so 5 times 1 is 1, so that means it stays as a 5. This here exponent is 1, this exponent is a 2. So what we have here is we have exponent 2, which is the largest. Let's take a look here. It says 2, because it is the exponent of the 2x squared. The x2 here means its degree is 2. Okay, next one. This polynomial has a degree of what? Now don't be confused. The x here is alone, but it does have an exponent. That exponent is 1, right? So this is the largest exponent of the variable. So that means this here is a first degree term, or sorry, polynomial. Now what happens when you have 2 of them here? Okay? So when you have x to the 2 times y to the 3 minus 2xy, what we do is take a look at all the exponents and you add them together. So 2 plus 3 gives us a degree of 5 for that term. And 1 and a 1 here gives us a degree of 2 for that term. So since this is the larger, that means that this here term, 3x squared y cubed, has a degree of 5. Now, variables. A variable is defined as any letter or symbol used to represent a number. Okay. Now it can be any number you want. If you have 2 variables, they cannot be the same. They have to be different numbers. So if I had an x and a y, like up here, this would be at one number, and the y could not be the same as that one. It would have to be a different number. All right. Now this x here and this x here are the same number. So if I said that x equals 5, this would be 5 squared, and this would be 5 to the power of 1, or just 5. For example, go down here. You could take a look at this. This is 3x squared minus 2x plus 4. You can write this or rewrite it with any variable you want. This is the equivalent polynomial, 3b squared minus 2b plus 4. So when you're creating them, you could use any variable you wish. The only rule is that when you're given a variable, you are not allowed to change it. So for example, in the question up here, if it said what degree is this, you have to stick with x's and y's because that's what you were given. Okay. So now what we want to do is we want to do a little bit of testing to see if you know what you're doing. So the first one we're going to do here is a polynomials in the first column, and what I want you to do is to determine what the degree, variable, constant, coefficients, one or more, and number of terms that are there. Okay, now you may not have a constant either. So let's take a look at the first one. I'm going to do the first one with you. Degree. You're looking for the largest exponent. That's a 2. That means our degree is 2. Variables. There's only one x in here. That means my variable is an x. The constant is the number that's by itself. That's the 5. There you go. The coefficients are the numbers in front of the variables telling you how many you have. So this is negative 2x's, so we have negative 2. The negative always stays with the coefficient, it never changes. And in front of here we have 1x squared, so the coefficient here is 1. So that means that we have here negative 2 and positive 1. And the number of terms, very simple, 1, 2, 3. There you go, the number of terms is 3. So, pause the recording, and I'd like you to complete the rest, and then we will go through it. Okay, this first one, let's take a look at the degree. We got a 3, a 2, a 1, and this one here, so this is a third degree. Variables, they're all x's. Oops, got the wrong one. The constant, the number by itself, now remember, the sign in front of it keeps it there, so that's a negative 6. Coefficients, I've got 3 now. I've got a 2, a negative 4, and a positive 5. And it's got 1, 2, 3, 4 terms. Okay. Taking a look at the next one. Negative 3a plus 6. Again, the a has an exponent, and that's a 1. So this is a first degree. Right. Now, next one. The variable, we're working with an a. Constant is the 6. Coefficients is negative 3. And the number of terms, 2. This one here, degree. Take a look at the exponent. The exponent here is a 1. So that means that this is got a degree of 1. The variable is a b. The constant is a negative 7. You got to include that negative with it. Oh, sorry, wrong way. That's the coefficient. The constant, there's nothing there. So this has no constant. Next, negative 7 for the coefficient. And of course, there is 1 term involved here. Now, this one's kind of tricky. What degree is this? Well, if you take a look at this, there's no variable, right? Because there's no variable, it has to be anything raised to the power of 0. So this is a 0 degree term. The variable, there's no variable. The constant is a 6. The coefficient, there isn't any. And number of terms, 1. Now, down here, remember, we have to add the exponents to determine the degree. 4 plus 2 means this is a 6th degree. The variable, we have x and y's here, so we have x comma y. The constant, the number by itself, is 7. The coefficient is a 2 and a negative 3. And it has 1, 2, 3 terms. Now, if you got any of those wrong, what I really strongly advise you to do is to go back and try it again. Erase it, put paper on top of it if you have it, cover everything up and go through and do this and do this and do this until you can get it correctly. All right, these are the basics. You're going to have a hard time if you don't know what we're talking about when we use these words. Okay, the last classification we're going to do, it's called classifying them by the number of terms they have. And these are monomials, binomials, and trinomials. Well, a monomial, like a monopod, has 1 term. And that means, here are some examples. 2a, that's a monomial. 5, that's a monomial. Negative 4b squared, that's a monomial. A binomial, like a bicycle, has 2 terms. Here's some binomials. 2b plus 7, negative 5x squared plus 3, x plus 4. Now, a trinomial, like a tricycle, has 3. So here's 2 examples of that. X squared plus 3x minus 4, 1, 2, 3. 3x squared over 4, this is still a polynomial because the exponent is in the positive exponent and the variable are in the numerator. So we have that 1, 2, 3. That's also a trinomial. Now, equivalent polynomials are polynomials which have the same degree and the same terms. So for example, I can rewrite 2x squared plus 3x minus 5 in several different ways. I can change their order. 3x plus 2x squared. Remember, this is a negative 5 minus 5. I can take the negative 5 and put it out front. Negative 5 plus 3x plus 2x squared. Or I can do it this way. Notice that they're all the same terms. They're all the same degree. So this is what we call an equivalent polynomial. They're all trinomials. All right. So now let's take a look at creating some polynomials with tiles. So the next step we have to do is we have to start working with our tiles. Now, we know these ones. These ones here are negative and positive ones. You should know these x's from grade 7. And of course, this one here is new to you, but we've talked about it. It's the x squared. And it's an x squared because this is x length, and this is x length. X times x, the area of a square, is x squared. This is a length of 1, and this is a length of x, so 1 times x is x. That's why that's an x. We have the same thing for our negatives. So let's do some representing here. 2x squareds. Well, I go back up here and I'll say, okay, an x squared is a large square, so the first thing I need to do is to create the 2x squareds, 2 of them. 3x's, so I need to have 3 rectangles. There's your 3x. And of course 4 means I have to have 4 ones. So there you go. 2x squareds plus 3x's plus 4 ones. Okay, pause the recording and I want you to try this one. Okay, first off I need to have a negative x squared. Well, an x squared is an open square. The negative x squared is a shaded in one. 2x's, well that's pretty straightforward. There's your 2x's, and of course minus 5 means I have to have 5 negative tiles. All right, moving on. Okay, let's take a look at doing it the other way. So first thing we want to do is figure out what is the symbolic term. These are the tiles, so the symbolics are all the letters and numbers. So taking a look at the first one here, this is an x squared and an x squared and an x squared. They're all positive, so my first term is 3x squared. Now, this is an x and that's an x, and there are 2 of them, so this is positive 2, and they're x's. And of course I have 1, 2, 3, 4, 5, 6 negatives, so the last term is subtract 6, because negative 6 and subtract 6 are the same thing. Okay, pause the recording and you try these 2. Okay, well, we've got negatives now. So this is a negative x squared and a negative x squared, which means our first term is going to be negative 2x squareds. I've got 1, 2, 3 x's, and they're all negative, so I have negative 3 x's, and I have a negative 1. So the next one down here, I've got 2x squareds, and they're positive. I've got 3 x's, and they're positive. And I have 3 negatives, and they are positive. Negative, sorry. So I have 2x squared, 3 x's, and 3 negatives. 2x squared plus 3x minus 3. Okay, that concludes the lesson, so try the assignment. If you have any trouble, please watch the video again, and we will talk to you in lesson 5.2.